Hello everyone. In this lecture, we are going to see ASME, Section 8, Division 1, Subsection A, UG 29 Steps to calculate required moment of inertia. We have all these courses available on our Thinkific platform. To learn more about these courses, register with the link given in the description.
Now see the different steps, how we will find out the required moment of inertia. So the first thing is to find the B value. Okay. So finding B value, and this is the same factor B, but it is calculated directly by using this formula. Okay. It is not calculated by factor A, but directly factor B. With this formula, we can calculate. So slightly different than what we have been doing right now. So once we have this factor B, we'll go to the applicable material chart and we'll find out the factor A. It is reverse actually. Okay. Now let us understand the same thing with the graph. We will first try to find out the factor B. Once I have the factor B, I'll move horizontally. I'll see which temperature line, like if my design temperature is 150, to that temperature line, wherever it is crossing, that will give me the, this cross sections. And if I move downwards from there, okay, if that from that intersection, if I move downwards, that will be my factor A. Now, anybody can tell me what factor A value here you will read? Just tell me quickly what factor A you will get. Because many times we struggle to read this chart. So let me quickly check. Give me this value, guys. 0021. Absolutely right, Himanshu. Absolutely right. So that is the value. 0.022 or 21. It can vary that much. Okay. See, it may happen that you will say that, okay, what if my B value is less than 16? So it will not touch any temperature lines, right? What if my B value is crossing 120? Okay, is it not touching any line? Then what I'll do? So that is where this value. So directly I can use this factor A and I'll be able to get this factor A value. Okay. Once the factor A value we have now all the required values to get the required moment of inertia. Just here the recall of available moment of inertia, which we have already calculated for this section. We will get the required moment of inertia by using this. Okay, here we are not considering the shell as taking part as a stiffener. So we have used the term 14. Now I'll just compare these two. Okay. This is the second case where the shell is also taken care. So, just try to see that. Okay. First one, I have only two areas. So when I'm calculating available moment of inertia, I'll get this equation and I'll have to compare with IS. Okay. Because shell is not taking part. Once the second case, when I'm taking shell also taking part as a stiffener, that also will be added in moment of inertia available calculation. And that will be cross-checked or compared with IS dash, where the 10.9 we divide. Okay. So once my available moment of inertia, if it is greater than required, then my stiffener is adequate, right? I don't need to provide additional area. If it is less, then it is not adequate. I'll have to consider a different cross section where I can get some more inertia or more closely spaced stiffeners, whatever may be the case. Same case is applicable for I dash also. So I dash is the available moment of inertia with shell also contributing as a inertia. Same case for that also.